innovation, we would like to introduce our mentor, which are Tiru and Shahir, and our advisor Puan Fazida. Before I move on, I would like to elaborate a little bit about innovation. Innovation is development of new values through solutions that meet new requirements and inarticulate needs. So we want to accomplish this. We extract ideas from other innovation, other readily available products, and we innovate and we improvise the product to produce a new product. And we want to introduce new things and effort to transform the innovation into economic goods, which means we want to help all the Popia makers, all the Makmal Popia to improve their work. Okay, this is the product that we want to invent, which is Popia roller, or we will also call it as Poro. Poro is the abbreviation of Popia roller, Po for Popia and roll for roller. To solve the problems that are faced by entrepreneurs who sell and make Popia for a living, we found out they have faced a few problems, which are they have difficulties enrolling the Popia due to the old method, which is time consuming because they do it manual, so it takes a lot of time for them and it is a little bit complicated to do that. So we believe that by using our product, it can improve their work and also reduce their time to produce a Popia. Secondly, they have a problem to maintain the moisture of Popia layers in order to produce crispy Popia because they have to monitor the Popia and make sure the moisture of the Popia is moist so that to make the Popia. And the third problem is we want to reduce the burden of the sellers from monitoring the production of Popia, because as you have watched the video yesterday, Makmal Popia have to do the making of the Popia all manually, and it takes a lot of time. And maybe the Makmal Popia can use their time to do other works besides monitoring the production of the Popia. So the objectives of our product is we want to invent an automatic Popia making machine, and secondly we want to produce machine that will help save time apart from increasing productivity
and life
quality because this product is really convenient. And thirdly, we want to enhance the economical values for IKS and to conserve manpower.
Hello everybody. So as Alifa just elaborated to you about how that we wanted to create this Popia roller, right now we decided to come up with a machine that is supposedly to be very convenient for these Popia rollers from all aspects of which we mean by material and apparatus, and it doesn't cost that much, so it could be affordable to these Popia makers, Makcik and Pakcik. This is what we envision our Popia machine to be like. It is not that big because it's mini Popia, therefore the size is just about this big, right? And it's very convenient to it doesn't cost that much, and you can buy a lot, so it could be done simultaneously, and a lot of production of Popia can be increased. So to start off, the materials that we decided to put inside this machine would be the button, the switch at the side of the machine to activate the machine on. Moving on, the main materials that we would want to use inside this machinery would be aluminium and also stainless steel. The reason why the casing of this machine that we want to invent would be made out of aluminium for several reasons. The first being that aluminium is relatively cheap, and it's because it's a very much abundant source, especially in Malaysia. So it's very easy to find, and it's not that it's very cheap. not only that, aluminium is also very lightweight and it's very strong. So it would be, and plus aluminium would be stronger if you made it into an alloy, which is optional if you want to make the casing stronger, and it's very durable. So the aluminium is going to be used as the casing for the Popia roller poro. Oops. Next would be the stainless steel, which would be used as our Popia machine. Our Popia roller would have the folders. Our Popia machine would have the folders where we would later on elaborate on how it's being functioned, but then there would be the folders to actually fold the Popia into, because at the beginning when you want to create the Popia you have to fold it, right? So we have these two folders and another one in the middle that is made up of stainless steel because it's durable and it's very easy to use, and whenever the Popia finishes it's very easy to clean. The next material would be the roller belt, along with the conveyor belt, which would be used for the Popia to be rolled into. Hani would explain to you, to everyone, how we will make the we will create the Popia into
how it works,
how it functions. Moving on, the next material will be the microcontroller, which would be installed, which would be used to program the poro, and will be installed at the back compartment of the roller where the folders are placed. So inside that box, so the microcontroller will be put inside that. That's basically the elaboration about the materials. Moving on would be the apparatus needed for our poro machine. Simple stuff like screwdriver, and then that would be the steel cutter to cut down the aluminium and whatnot. Also the soldering and welding machine, because to join the metals together, the aluminium, the stainless steel and such. So basically that is what we want our poro machine to consist of. To give you an idea and overview about how we want our poro machine to function, we would like to show a video about it.
So you see this machine, how it works is that it will roll the sushi. So we find that this idea is very similar to how you roll Popias, just that you have to add the folding mechanism before you roll. So the conveyor belt will turn clockwise, and one will turn clockwise and the other one will turn anti-clockwise, so that the conveyor belt, the white one there, will fall to the middle.
Right.
So,
So moving on.
This is practically an overview of how things are supposed to work in order. First, we put the spring roll there on the machine. Wait, not tunjuk ni. So that is the front view. So you can see the folding mechanism there, and you have to put the crust on the folding mechanism. As you can see, the folding mechanism and the roller belt is not really that far in distance, because we don't want the Popia to fall with too much force. Otherwise, it might, open up. And how it works is that first, when you activate the switch, when you activate the machine,
Front, left, right, right. Right, yeah.
The front roller, the long one here, will rise first before the left and right ones, because we have to fold it.
Vertically, horizontally.
Let me
Demonstrate.
First, you have to roll it. Let's say it's in the shape of a square. So first, you have to fold it here. Diamond. You have to fold it this way, and then this way, and then this way, and then the rolling mechanism will actually fold it to become like this. So the first, the folding mechanism, the first one, the rod in the middle, will push this part of the crust forward, and then the second one will, the second roller, which is the left one or the right one, it can be any way, it can be in any order, the left or the right one, because it's practically the same. So when these two rise, it will lift the crust this way, and will fall onto the middle. So at first, we had a problem of thinking, what about the Popia which we already folded? Won't the folding rods be in the way? But then we just realized that if we folded it this way in the middle, so the rods will rise upwards and it will fall onto the rolling belt. So after that, we have two rollers, as you can see. This is the sideways view. Actually, this is covered by an aluminum casing, just the top is visible. So one roller, the front one, will turn inwards and the other one will turn the opposite direction. That's what causes the roller belt to fall inwards. The roller belt is not that tight, so it can still stretch to the middle, because when it falls to the middle, the Popia will roll like as demonstrated with the sushi video just now. So it will have, and then after it is rolled into the middle, both rollers will turn the opposite direction as they have before, and the Popia will jump out, and you just have to put on the tapioca or glue bikayu. And after that, you have one finished Popia. Yeah. You have one finished Popia. So
This process takes a
this process is actually not as complicated as rolling it with your hands. Probably someone who has lots of experience will be able to do it very fast, but there are some people, there are people who have difficulties doing that, especially people who have arthritis or carpal tunnel syndrome because of doing too many complicated, because of using their fingers too much. So
The process is very short.
so this actually shortens the process, because you just have to place the crust, place the filling, and then you push the button and you're done.
Now it is all about the cost and the money. If you have the idea but you don't have the money, you can't convey your idea into a working machine. So now let's start with the stainless steel rod. Okay, this rod will be used to fold the Popia. Okay, we will use a stainless steel because it is a food, so in order to ensure the safety and the cleanliness, we have to use the stainless steel rod. We need a 1 meter and a diameter of 20 millimeter or 2 centimeter. Will cost us about 100 ringgit Malaysia. And another is rubber conveyor belt. It will be used to fold the Popia, and it costs us about 200 ringgit. Okay, next is the stainless steel roller. We need to roll the Popia. We have the belt and the roller. So because of it is sold in 1 meter, we can cut it to half. So we will use only 200 ringgit. Next is the aluminum cover to cover the body part of the machine. Well, we need 10 as aluminum is sold in kilos. So I think we need 1 kilo cost is about 20 ringgit, and if we need 10, the overall cost will be 200 ringgit. Next is microcontroller. As we know, to control the machineries, but all of us will be given one, so it doesn't cost any ringgit, any cent. And another is switch to control the machine, to on it, to make it work. Next, screwdriver, soldering and welding machine, steel cutter, and also the motor. Okay, alright. Now, if we take a good look, it will just cost us 1,000 ringgit Malaysia. So I think it is affordable and reasonable for the IKS, for industry, kecil and sederhana people, to make it
investment
as an investment for them. Alright, thank you.